Namaste and welcome. This is a session on sampling and sample size for Health Research Methodology Workshop 2025 conducted by Research and Scholarly Activity Committee of Patan Academy of Health Sciences. My name is Shital Bhandary. So where does this session fits? I am sure that you have already reviewed a lot of resources that was available in Moodle. So we started from critical review of literature, followed by annotated bibliography and gap analysis. Then we went to research question formulation, then evaluation of the research question, then formulation of research hypothesis, and research title topic, followed by study objectives. So today I'm going to talk about study design, sampling, sample size, and a little bit about the statistical analysis also. So basically in clinical studies, we talk about four study designs: cross-sectional, case control, cohort, and experimental. So cross-sectional is a snapshot in a time. Case controls is done when we have two groups. Usually it is a retrospective. Cohort is a prospective one, and experimental where we can manipulate how we want our experiment to be. So regarding population and sampling, population is the whole population. So think whether you can study the whole population of Nepal or Lalitpur district. Then maybe you want to focus your scope to target population, for example, type 2 diabetes mellitus population, and ask whether you want to study whole population or do you want only to confine to study population, which is a sampling of the type 2 diabetes mellitus patient in a single center like our hospital. Okay, the question is how. So if we want to generalize our finding, so we have to use the random sampling. So there are four types: simple random, where we choose the subjects based on the sampling frame. It is also called a lottery method. Then we have a systematic random sampling where we select a participants based on a fixed number of interval. Then we have a stratified random sampling where we select the participants by groups and then randomly in a group. Then sometimes we also need to select the samples using the cluster sampling, where it is done in the area or a group like hospitals, schools, or communities. The sampling frame is very important for random sampling. It includes a list of all the population. This list should be obtained by us, or we should be able to prepare it if it is not available to us. This is very important. So, for example, we can have a list of all type 2 diabetic mellitus patients visiting OPT of a tertiary hospital. And then we can prepare a list of similar patients living in a local community. Then we can do a random sampling. So we can do random sampling manually, or we can use a spreadsheet like Excel to do that. So how many samples to collect is given by the sample size, and that is what we are going to talk next. So before that, we need to also remember that we already discussed about this one, general and specific objectives. So there is an example. So for example, let's say if we want to assess the body mass index and its risk factors among the patient visiting medicine OPD of PAHS, then we can frame many specific objectives like estimation of body mass index in that particular sample, compare body mass index by sex, or compare body mass index by socioeconomic status. So there are three specific objectives. We need to calculate sample size for all the specific objectives. Similarly, if we want to assess the prevalence among these patients visiting in our hospital, then we can estimate the prevalence, then find the association between the diabetic status and the sex, and also find the association between diabetic status and the socioeconomic status. So remember that we need to calculate sample size for each specific objectives. So here is a simple formula to calculate a single mean, and this is an example that so this value comes from a study done UTH in Kathmandu Valley. So margin of errors, I have taken 5% here. You can take 10% if you want. The sample size came out to be 56. So it's very easy to do in our study purpose. But remember, the sample size is only to valid to calculate the mean. You cannot use it to compare the mean. For that, we will be using different formula. So you can actually verify your sample size calculation from this website. You can see the sample size is same, and if you add a 10% non-reference or dropout, then the sample size will be 63. Similarly, if you want to estimate the prevalence, then this is the formula. The same article reported the prevalence in the diabetic clinic as 42.85%. So with a 5% margin of error, the total sample size was 377. So again, this is valid to calculate the prevalence or estimate the prevalence. We cannot compare using this sample size. So this is the same calculator, but for the proportion. So you can see we got the same value. So with 10% non-response rate, the sample size increases to 419. So if we want to compare in two groups, mean in two groups, then this is the formula that we can use. So I have applied this one using the same article. So the sample size came out to be 100 in each group. So I need 200 sample size total. So 200 is more than enough for us. So using this, you can compare BMI by sex. So we'll be using the t-test to compare and report p-value as well as effect size, because now we are using effect size instead of margin of error, because we are using both alpha and beta errors. So this is the website that can be used to check your sample size calculation. And similar can be done for the proportion as well. The formula is given here, and the value is taken from the same article that I showed to you. So effect size is difference between male and female proportion 0.03. Because the difference is very small, the sample size is very large now. So each group has must have 4,360 samples. So remember that this might be difficult, but if you want to do it, so use chi-square test to compare and report p-value as well as effect size, like I have explained in earlier slide. So checking can be done using this website again. So if we want to compare more than two groups, a mean of more than two groups, then one-way ANOVA can be used. So if we want to compare prevalence by more than two groups, then same one-way ANOVA can be used, but the proportion here, instead of mean, proportional will be used. Okay, so here chi-square test will be used, and we will need to report p-value and the effect size. So this is the formula. The one of the difficult thing here is to calculate the NCP, which is the non-centrality parameter. Usually we need a software for that one. So here I have given you an example. So if we don't have a raw data, then we can use a effect size given by Cohen's. So here the medium effect size given by Cohen for one-way ANOVA is 0.25. So with that, the sample size was 158. But since we had three groups, so if we divide that by three, so each group will have roughly 53%. So this is how you can do the sample size calculation for more than two groups. You can check it using this website, and same result you'll get. So you can use the same concept to compare more than two proportions. The same formula, same concept applies. Okay, because we are using the effect size, we are not using the proportion or mean per se. So, for example, if we want to use regression, then we can use that. So, normally in regression, we use a software. The concept is same as ANOVA that we have done. So, for example, for a linear regression, the effect size is now medium effect size is 0.39, which is given by Cohen. I have taken a number of predictors as three. So, for example, age, sex, and socioeconomic status. So, based on that, 76 sample size was required. And there is also a rule of thumb. I would not recommend it highly, but sometimes it comes handy. So, for example, the rule of thumb given by Green gives us the nearly same sample size, 74. But if we want to compare the regression coefficient by variable, then we need to use another formula, which is given below. So 107. So between 74 to 107 sample size is required by the rule of thumb, but I think 76 is more realistic one. So this then similarly we can do it for the logistic regression as well. So here I have taken a odds ratio of 2. And then I have done the calculation using this software. The explanation is given in the right hand side. So total sample size was 185, and this is for the bivariate model, means one dependent and one independent variable. But let's say if we have a more independent variable, then we need to factor in the that more variable using the concept called VIF. So VIF can be calculated and the total sample size must be multiplied by VIF. So I have done it here, and the total sample size for uh, new sample size for multi-variable logistic regression comes out to be 246. Sometimes you may want to do the study for diagnostic accuracies. So this is the formula given in one of the articles. The link is given here. You can go to this link and read more about it. So for example, let's say my sensitivity is 90% and specificity is 85% from a literature and prevalence of a disease is 20%. Then the precision of that particular estimation is 10%. So with that, the sample size is 173 for the sensitivity and 62 for the specificity. But since we take the largest one, so the final sample size is 173, and with 10% dropout or non-response, it will increase to 193. So this is for diagnostic accuracy type of studies. So we can get sample size for ROC-PAHS, area under curve also. So you can go to this slide, this site, and do the same. The formula is not given, but you need to find that. It's not very difficult to find the formula for this one. Sometimes we need to have a sample size for correlation also. So in this website, they have given the formula and an example also. So for example, if I want to calculate a sample size for correlation coefficient of 0.2, then the total sample size comes around 194. So the reference is also given. You can go and look at the reference also. And sometimes we also need to find sample size for agreement coefficients like kappa. So this calculator gives you that. Formula is not given, but you can find it very easily in the web. So for example, if I expect the agreement to be 85% with 5% error, then I need to have a 554 samples minimum. Okay. So people also do a lot of calculation using Cronbach alpha, which is also known as internal consistency reliability. So we can also get sample size for that one. And same concept I have used here. So for Cronbach alpha of 0.8 with 5% error, I get a sample size of 142, where the number of items that I included in my questionnaire is to be 10. So please make sure to change these values whenever you calculate sample size for Cronbach alpha. So this is all from my side. So if you have any questions and queries, we can discuss in our synchronous session. So thank you very much, and please review the slides before coming to the class. Thank you. Thank you very much.